Okay. Sorry, Priyanka, hold on. Oh, you didn't have to do it for the picture this morning, but you do have to do it eventually. For the end of the chapter test review. You know what I mean? Sorry.
If there's 2 columns in the homework and we didn't do it because we didn't find it, do we need to go back and do it?
Don't resubmit your pictures. That's totally fine. Just do it so that when you turn in your homework spiral at the end of the chapter, it's done. Yes, but not resubmit pictures. Some people think they have to go resubmit, but no, you're good. Okay, sorry, Priyanka. What we're doing today, our mission is to go ahead and talk about intermediate value theorems so that everyone can finish their homework. Those of you who submitted it for today, you could have skipped number 95-ish or whatever, 1 or 2 were on this theorem. But then everyone needs to have it done by the test day anyway. Some people still need to turn in coffee bonus still until Monday. It's applicable. Yeah, and then we need to get into section 2.3 and not just get into section 2.3, but do section 2.3. But there must be some reason I think we can do section 2.3 in one day, because we just looked at Google Classroom, and Google Classroom has, take a breath, homework number 13 due on Monday. So what, I don't just randomly pile on the work, so hang in there and let's go see what it is, yeah? But to see what it is, we got to finish 2.2, so we'll come back to 2.3 in just a second. Otherwise, super good to go besides me just saying happy Friday, you made it to the end of another week. Take a deep breath. Let it out. And if you guys don't mind, I pray for both periods 1 and 2 and 3. Actually, I shouldn't say both. I've heard that cross-country kids had a busy weekend with Bell Jeff. I know volleyball kids are tired from a well-fought game last night. I know that other kids, I know juniors this week had some really tough stuff. Sophomores, I heard WAP is brutal.
WAP is brutal.
I think we're tired. Or we're going to be. And we might need a good weekend. So if you guys don't mind, I'm just going to pray real quick for you guys and for the weekend and for our class period today to be productive and useful. And for Mom, because I'm trying to raise you for this. It is her birthday. You guys didn't hear it's Mabe's birthday today, which is kind of cool.
Who is Mabe?
Mabe is the one I was talking about in chapel on Monday, who's the site leader of the women's volleyball site down in PR.
Oh, okay.
Rebecca Neighbors, Priscilla Kendrick, Cassidy Rosso, and Natalia, who didn't know volleyball, but volleyball is hard. That was her lesson. Had fun working this. Yeah, she got jumped by 2 teenagers on the way home from dropping our girls off at base after a dinner at her friend's. Like they have dinner in the community. She was on her motorbike, and 2 teenagers tried to steal it. She didn't give a lot of detail. She didn't really talk a lot about it to Cass, but she did say that basically she was scared and she got away, but she's like, I need a car. So that kind of got Cass thinking, and then she wanted not all Cass, but I know as far as like I would love to come back and raise my kids, so even more kids.
I should bet Crown Vic incentive right now.
Huh?
Like you just need $1,000 to buy like a good Ford Crown Victoria and like $2-3 grand to send it there. That's all you need.
Well, the problem with ascending, like there's a lot of taxes and whatnot. We have Dan and Twyla Krasinski. I don't know if you guys know them. Back from Tyler would have been about your age. We asked Dan because he's been living down there for a few years, and he and Twyla were like, yeah, she really needs this. You guys should totally make this a project. And they're totally like, we're good on support for right now. Like, don't worry about us. Focus on her. And he said to buy a nice car, it would be $5,000. So we're just following Dan because he lives down there. And she also needs to go up in the mountains, so I think she probably needs something
Like a 4x4.
Yeah.
She needs a Hummer.
No.
Yes, she needs a Hummer.
I'm not specifically getting it. We're just sending her money and then she's buying it. But she, like, one of the new volleyball sites is like literally up in the mountains without paved roads, and so she's been doing it on her moto because when teams aren't there, she can't go. Like, she can't borrow a base car, but she uses an SUV from the base when teams are there. So it's pretty. Yeah, between the jumping and between her having to traverse.
I think she's a brave for as well.
Yeah.
I'm going to the whiskey tonight, so I figured I'd get some whiskey and a go-go.
It's going to what we're assuming is a shady place.
It's not crazy shady, but like
there's a little bit.
it's a concert. It's Guns N' Roses.
I'm going to the Guns N' Roses.
Oh, you're gonna love it.
My dad went to Guns N' Roses concert.
But it's whiskey and a go-go. That's like kind of.
No one knows what he's gonna go.
You guys should.
All I have to say. Let's go ahead and pray. Huh? Jesus, thank you for this week that you've brought us through. Thank you for our stories, each of our individual stories. God, they're so diverse. They're so different. Our interests are different. I mean, our ages a little bit older. But these kids even, there's just such diversity in front of me, Lord, and such beauty in that diversity. Beauty even in the midst of pain. Some have been through relatively little. Some have been through a lot. Some have felt pain in deep ways that they can't even express, and they're still trying to heal from. And some are just kind of like floating through life. But it's going to hit one day. Lord, I just pray that in all of these different situations, the good, the bad, the ugly, the easy, that we find strength and comfort in you. Lord, I praise you for the hope that's found in you. I praise you for the hope that's there for Mabe and for all these kids that she works with. But I also praise you for the opportunity that we have to bless her. And just in something that's relatively, in a sense, in the greater scheme of life, small. Pray that you can bless that effort today and give her a good birthday. And let her know that she's loved and cheered on by so many, both down in the DR and back here at home. Lord, I praise you for each and every one of these kids in period 4 honors HPrecalc. They've been working hard. My WAC kids, my juniors, my athletes, and even my cross country kids have a big meet tomorrow. Volleyball kids had a hard-fought game last night. Lord, I just praise you for all the different ways they're striving to use their talents and their abilities. Pray that you watch over them, protect them. I pray that they can, in their own unique journeys and their own unique talents and abilities, Lord, just feel your affirmation, your love upon their lives. That's unmerited, that they don't have to earn, they don't have to work for, they don't have to reach perfection to gain, but instead that's a completely free gift from you that they can rest in and then just walk confidently in the freedom and the life of Christ. Good today as we do some math, we can do it well, we can do it for your glory. We can do it in a way that's efficient and helpful for the days ahead. In Jesus' name, amen. So, intermediate value theorem. I watched over Alex tonight at his concert, totally forgot, but Lord, you know that he's going to this maybe somewhat a little bit shady place, but Guns N' Roses, it's awesome, he's going to love it. At the same time, Lord, keep him safe and all those he's going with. In Jesus' name, amen. He would have remembered, but still. Since I remembered, I wanted to just remind him.
Is this something where it's like you change everything from like positive to negative?
No, you're thinking absolute value.
No, not that. There's like something, I don't know what it was, but you change like all the x's.
Like
negative.
even odd.
That's symmetry.
That's even odd
That's
symmetry.
No,
symmetry.
it was something we learned last year. I don't know what it was.
I don't think so. Do you guys remember the name intermediate value theorem? It kind of sticks out as being like, ugh.
All I remember is theorem.
I think
Let me
we
finish on that. Anyway, for a while. I don't know. I could look in the Algebra 2 textbook and see if it's there. But let me say the idea of it first. Because, I mean, when it gets into math, maybe it'll be hard, but to be honest, it's not. Because the idea is height example. The idea is height example. I forgot why I was talking about height in period 3. Because we went over this too. Like the end of their class right now is the beginning of your class. It's kind of how we are. We're going to jump ahead soon. But for some reason I was talking about height, and I was talking about the movie Tall Girl, and I don't know, I was talking about all sorts of stuff. Oh! Because I had to like kneel down to write something so they could do the notes, and I'm like, sorry, I'm tall, I'm going to get down here to write this table. Anyway.
I'm not familiar.
Don't worry. They got distracted too. I haven't watched it, I'm sure I want to see what I heard the ending, and I was like, But.
Some dance songs too.
Okay.
You guys did not consistent call, actually.
Yeah. I don't need to hear them. But I know enough that I would probably relate well, and there you go. Cass was like, I'm never going to watch it.
He's always talking.
Coming back. No, it's okay. God has made me the height that I am, and you the height that you are, and it's good.
Sure.
Coming back. Height example, intermediate value theorem. Ready? I want you to tear these words apart. Alec just said that you've seen theorem time and time and time again, so that's not really helpful for remembering it, right?
Yes.
We have intermediate and we have value. Intermediate, you guys know beginning versus advanced. Intermediate's in the middle. True? Now, not directly like midpoint middle, just somewhere in between. So I want you to think intermediate in between. So intermediate, in between. In between value, I want you to think, ready? Function value. Function value. Like f of x value, like y value. Height example, ready? I don't know exactly how big I was when I was born, but I was pretty big. I was a big baby. 10 pounds, 11 ounces. If you know babies, that's good thing it was a C-section. Full head of hair. Okay. I was born July sweet. That's easy. Okay. Now I'm here. Question. Whatever size I was when I was born, in my lifetime, have I been 3 feet tall?
No.
Yes.
That was an easy question. Yes, I was. How about 5 feet?
Yeah.
How about 5'1", 5'2", 5'3", all of your little heights? Yes, I have. Don't worry, I love you all. You can make fun of my height. I can take it.
6th grade.
Coming. Yeah.
Who knows
Anyway,
why?
Now, question. Why do you know this? Why do you know that I was 5 feet at some point in my life? I'm sure not now. I'm taller. I have surpassed 5 feet. And how does height work?
You can't like skip height.
I have to pass through all of the in-between values to get from one place to another place because of how height works. Because height is, ready, a continuously growing, well, or some people shrinking function.
No, Izzy grew a lot.
But there aren't many, there are people that grow very slowly, but there aren't many that are the exact same size they were when they were born. There are some conditions, you're right, where it is
Rob,
but all of you weren't born like this. So coming back. Okay, height is a continuously growing function. Now, is it a linear function?
Not always. Wait,
What do
yes,
you mean?
No.
Not
You
ever.
never can go back down, right?
You have to think about what I mean. You're in honors, come on. Huh?
Because never go back down.
I'm just
Wow.
Oh, you can't.
My dad definitely shrunk.
Oh, maybe she got taller.
How tall?
No. Like, there are, like,
How tall's
actual
your
people
dad?
that have shrunk.
You don't like.
He likes to think he's my height, but he's
He likes to think. Do you like tower over much more?
no, not taller. But he also had a hip surgery, so like one leg shorter than the other. That's part of it. But even like when people get older, yeah, they start
Well,
to.
they start shriveling.
Yeah.
Okay, stop. That has nothing to do with my linear question. Lines can, okay, lines don't go down, that's true. But why does height have to be a curved function?
Because it's like, it's quite.
Because it's.
You guys have totally left school for the summer, come back, and there was some boy in your class that was like here, and all of a sudden he's here, and his voice is like here, right? Well, maybe that hasn't happened yet. Just wait.
What?
It'll happen. Justin Liu is a great example. He was here, and then he was here, and his voice was like. Anyway, so it happens. It's a thing called puberty. So coming back. There are guys who
Lucas.
all of a sudden you're like, whoa, how did that happen? I was kind of more of a linear-ish one. Like I was always kind of on the upper, taller end. Some people just kind of stay down here their whole lives, and it's okay. I mean, they grow. And then there are guys that are like still waiting for like, please God, please. Anyway, and it happens in college. It does happen. But coming back, it doesn't matter whether it doesn't matter whether height is linear or whether it's curved, whether for some people it's lower or higher. What matters for you to know that I was 5 feet, or for me to know that you were 3 feet, or for me to know that some little kid who's here at one point was like 1 foot, right? Now we have to think about how big they were when they were born, so maybe. Okay, but coming back, it's because height is a continuously moving function. Check it. A continuous function must have, now this is one application of this theorem. This theorem actually says to go from point A to point B, you have to hit through all the in-between values. Function values. Wait, function values, aren't those y's? And aren't y's heights? Okay, so intermediate value theorem, in-between y value theorem, in-between function value theorem says, one application in which, if at a certain x value, if at a certain x value is called hint A, my point is above, aka a positive point, and if at some other x value b, my function is all of a sudden below, and it's a continuous function, what had to happen at least once? Whether it was a line, whether it was a curve, whether it went lots of times, what had to happen? It had to have a zero, it had to go through, technically, all the points in between, all the heights in between. But specifically, for our purposes, it had to have a zero. And if somewhere else, at some c, my function value is negative, and at some d, my function value is positive, if the y's are here and then here, if it's a continuous function, it had to pass through a zero somewhere. Maybe once, maybe twice, maybe a million times. But it had to pass through. Maybe in a straight line, maybe in some sort of curve, maybe in some sort of up sort of thing where there's lots of them. Yep, you're welcome. But it had to hit 0 somewhere. So how do we use that? Intermediate, in between. Value, function value, height value. Well, what if I give you something like this? When you still writing? Okay, I got you.
No, I just meant nothing.
Yes, we're trying. It's not that bad.
Yes, it is.
Here's the deal. Here's the deal. Section 2.2, you guys should have already done this homework, and as you did this homework, you should have seen that we were seeing higher degree polynomials. But your higher degree polynomials, your cubic, your quartic, your quintix, would have all looked kind of similar until maybe something like number 96, because they were giving you really, 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 really nice functions. That's not nice, that's disgusting. Oh no, it's nice.
You can factor it
It's
out.
a 6th degree, but there's a, yeah. Do you remember what it's called, Alex? When you can pull out?
Called factor.
GCF.
GCF. So when you pull out a GCF, you can pull out that 25x to the 4th, which, yeah, it's gross, but at the same time, you get an x squared minus 25, which is a difference of squares, which means pretty quickly I can have my entire factored form of this super nasty septic? Oh, that's weird. Yeah? Like a septagon. Wait.
No, it's hexing.
I don't think it's hexagon.
Hex is 6.
There's
Sept is
7 to 7.
that's
Like a septopus.
Hex, like
hex. Yeah, I guess.
Hex
I thought
like
there was an
hexagon.
S for 6.
Yeah,
Maybe I'm
hexagon.
totally crazy.
draw the hexagon.
All right,
See how
fine.
many
A
sides it has.
hexagon polynomial.
Wow, you showing me.
Yeah.
A 6-degree polynomial, just kidding. He could have had 6 different factors. He ends up only having, well, he has 6, but this one has been multiplied, right?
Yeah.
He has a multiplicity of 4. So I have 4 of them there, and then 5, and then 6, but I'm only going to see 1, 2, 3 intercepts. They gave you nice ones in homework. Bless you. They gave you nice ones in homework, but guys, section 2.3, we're going to the nasty ones. Oh, seriously? Don't worry. Don't worry. We're just going one step into it. We're not going all the way. That's not until later. But section 2.3, we're going towards the nasty one. This is an example of a nasty one because can you take out a GCF? No. So this is an example where we're going to talk about IVT for a second because in just a moment, we're going to go looking for his zeros. How easy was it to find his zeros? Because I can just say 0, -5, +5, I'm done. But in this guy, if I can't factor him quickly, I'm not going to find his zeros quickly without my calculator. So the idea of the intermediate value theorem says, if you can plug in an x, and it's positive 1 second, and plug in a nearby x, it's negative the next, guess what had to happen? Guess where to look and to zero in to try to find your zeros? Right there. If you see the positive to the negative, you're like, I know there's a zero somewhere. If you see a negative to a positive, I know there's a zero somewhere in there. And this is going to be helpful if, in a few sections, you get a nasty polynomial with a lot of different possible zeros to go looking for. If you can like take a little range, take a little window, take a little interval, and figure out a sign change, you can say, forget all those, I'm zeroing in right here. Ha! I got one. And once you got one, it's easy to get the second and the third and the fourth, and however many you need to find. So, we're going to be looking for sign changes. Now, if I just had you go to your graph to go find a zero, it defeats the whole purpose, because you're like, well, I can see the zero, it's right there. The point is, in the future, we're not going to have the graph. We're going to have the equation, and we're looking for the factors, and to find the factors, we're going to have this whole list of possible factors, and we don't know which ones are real or true. And to narrow down our search, we're going to go looking for sign changes. So where do we go looking in a quick, efficient way for right now, just to save time? A table. So what if he's supposed to disappear? Forget it. All right. So what if I zoom in? What if we threw this function into our calculator? Now, in the future, we're not going to have a calculator. We're going to be doing this by hand, just trying to narrow down our search. In pre-cal, we had this whole life talk today about the usefulness of math. and how if you can understand math better, you can do shortcuts more often. So in a way, you're not just working harder for hardness sake, but you're working more efficiently to get the job done. We talked about how workouts aren't always effective unless you're doing them right. And not all workouts are for all people.
Mr. Hart.
He's doing workouts with very specific goals in mind, just
Greg
like
does is run.
football's doing workouts with very specific. Don't you guys do leg swings and all that sort of stuff too? Do you do like core? Do you do like cardio? And it's for their purposes though. Do you want cross country runners to bulk up? No.
Yes.
No.
I do.
Do you want football players to bulk up?
No.
Yes. Depending on the football player. Never mind. Let's not talk about each other's teams. That's a bad idea. Hey guys, look at the table. Check it. Are these going to be nice, even, perfect zeros? No, because look, I have all the counting numbers, and there's a sign change in between -3 and -4. There's a decimal zero somewhere in between. But I know where he is, and I know where to narrow my search. And then, all of a sudden, well, I don't see anything, booyah, I see another one, and booyah, I see another one, and guess what? If I went down a little bit further, booyah, I'd see a fourth one. How many possible zeros can this guy have? 4. Do I need to go looking anymore? No, I found them all. There's one in between here and here, one in between here and here, one in between here and here, etc. If I can find sign changes in between whole numbers, booyah, I know there's a 0. But technically, that still doesn't quite get me quite there. So what if I was to even go further and say, well, maybe I should go by 0.1s or 0.01s? I'm just looking at this -4 to -3, dude. What if I go by 0.1s? I can figure out, hey, pretty fast, booyah, I see it's in between -3.1 and -3.2. For some people, that would be enough of a degree of accuracy because you can tell it's closer to this guy. But some people might want more decimal places, so we go even further. And we find a sign change, and we know exactly where it is, and it's closer to this guy. And then you might want more decimal places. Do you guys realize that your calculator only gives you a 0 with so many decimal places? And sometimes there's that weird 0.99999 or 0 point where you have to like realize what the calculator's telling you, like e to the negative whatever. What if your calculator does this process to find the zeros because it's not really finding it at all? It's just finding sign changes and getting as many decimal places as it can give you. Huh. Interesting. Maybe your calculator doesn't know math as good as you do. Where was the actual 0? -3.112943. What if it was doing this process and then it just stopped as soon as it found that last sign change and said, you don't need to know anymore, so here's the answer. Huh. Interesting. P.S. Remember, what do you do if you see something like E -12? Is it really E -12? Nope.
0.
It's 0 because think it'd be -0.000, 11 zeros in 1. This is 0. Remember, it's the best the calculator can do because it's doing this whole only so many decimal places rounding thing. That's IVT. That's what you needed for the end of your homework. We do have this thing called sign charts, but we'll talk about him when things get hard. How'd you guys do when you face something like this in homework?
I know.
Oh, it's not as bad as you thought.
No, you just gotta think.
Yeah.
You want to agree, is it? If it's like the cactus type thing.
GCF.
Okay, so you guys had some stuff in homework that was similar to this. I need to make sure that you're doing it right before we go do section 2.3. Ready? Hopefully you guys would have pulled out, yes, the GCF, and hopefully pretty soon you would have gotten to your difference of squares. What is factoring really, 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 really good for? Those guys. So technically that's not even our first objective. Our first objective is this guy, right? Leading coefficient test. You find your leading coefficient and you say whether or not he's positive or negative, considering the degree of the polynomial. True?
Yeah, it's this thing.
Considering the degree of the polynomial, Alec already is like, it's the one that's opposite, and he's totally right. But which one is it when I have a positive thing?
It's gonna be, yeah.
But the problem is, can you write that in mathematical notation the way I put it?
The as x.
Exactly.
As x which is
Yes.
positive because y equals positive.
So, since I told you yesterday, for those of you who were totally in tune with what was going on. I want to see the notation, not the words. Now this does mean to the left and to the right. The book is going to be saying to the left and to the right, but we're learning the notation that will be helpful later in chapter 12. Now here's the struggle. If you go to Calc Chat to check your answers or the back of the book, is it going to have the notation you were supposed to have on your paper? So when I go check and grade your homework on Google Classroom and I see the increasing, decreasing, not the arrows, what am I going to think?
You're a communist.
Either didn't pay attention in class, didn't understand in class, or just stealing from Calc Chat. Now, either, all three of those are options.
There's 4.
But what's the fourth one?
Sleep.
Oh, they use the whole increasing, decreasing.
Nice.
Long story short, you didn't do it my way. So maybe some of you need to put a comment and say, so sorry, I didn't realize I was supposed to do it your way. But coming back, my way is to the left, to the right. What's going on? Well, to the left, he's going down. And to the right, he's going up. Because we learned yesterday that arrow stands for approaching. True? Yeah. Okay, but letter B gets into that whole zeros thing. And that's the whole thing that the intermediate value theorem is supposed to make easier. For the whole zeros thing, we would set f of x equal to 0, which I would set your factored form equal to that. Because then, do you guys see there are 3 factors? 1, 2, and x minus 0 is a factor of 2, right? So we end up with our zeros of x equals 0, negative 5, and positive 5. If you think about a cubic, that's the maximum number of zeros that he can have, which means he has some of those Humpty Dumpty things in between. Letter C says, oh, some of you are going to get stuck on that, or might have gotten stuck on that. Remember, we're not creating specific homework, but I am trying to give you a couple hints about if you got stuck, where you got stuck. If it says plot more points, plot sufficient points, it means you need more than this. So I'll show you the more. I'll show you how I do the more. And then we'll talk more about it when things get harder, because right now you didn't technically need the more. Because some of you might have just gone ahead and said, I know there's a 0 there, and there's a 0 there, and there's a 0 there. I know he's going down that way. He's going up that way. These multiplicities are 1, which means the graph has to cross through each of these, which means he has to come up, and if he's coming up, well, he has to come down. Well, if he's coming down, he has to come back up, right? And some of you would have been, swoop, there he is.
That's what I did.
The problem is, did you realize that the swoop technically goes up to like 50-ish? And goes down to negative 50-ish? Some of your graphs were horribly shrunk from what they should have been. But how could you have known? By plotting some more points to give you an idea. Technically, how I would tell you to do it is figure out your intervals formed by your zeros. Test a couple points. Well, we'll do test 1 point. And then we'll do the function value or the y value by plugging in. So our intervals would be, if we were to do a little baby number line, and think about all the x's represented on the axis when you're splitting at 0 and negative 5 and positive 5. We would have from negative infinity to negative 5. That would be one part of my x-axis. From negative 5 to 0, from 0 to 5. And once again, I realize some of you wouldn't need to do this. You would just be like, what's going on at negative 2? What's going on at 2? It's close enough. But this is preparing you for something in calculus, so I'm just showing it to you. Introducing it now. I would plug in something like negative 6. He's some number on this part. Negative 6, and if I got a point for him, I'd have a good idea. I'd plug in something like negative 2. Well, to be honest, if I was super lazy, I'd plug in negative 1, but if I'm being strategic, I should kind of get halfway-ish. So I'd plug in negative 2-ish, and I would get that positive 42-ish to let me know to go that high. And then, to be honest, the better you know your math, the lazier you can be while still being efficient. I know this guy has odd symmetry, which means I know if I plug in 2, if he's positive 42, guess what? He's negative 42. That's sweet. And I can plug in my 6-ish, I think we ended up getting like negative 66 and positive 66 because I can use my symmetry again. But then you can get a much more informed graph. And from all the different classes that you're taking, shouldn't you be making informed decisions? Anyway, that's what we call a sign chart. There are times when I have kiddos like write down all kinds of notes on the sign charts, but for right now, for you guys, I'm just going to put a little star by it and say, that's what a sign chart is. The book doesn't ask for it, but I refer to it from time to time, and I use it especially on the nasty ones, which remember, we haven't technically really seen yet, unless we're allowed to use our calculator like that IBT dude a second ago. We were allowed to use our calculator on him. The other guys had GCFs. I'm pretty sure. People that tried homework, did most of them have GCFs? Yeah, good. Okay, so what on earth is section 2.3, and why on earth do I not think we just spent like 3 days on that section? Well, we spent like 3 days on section 2.1. What on earth is 2.3, and why do I think we can do it in 10 minutes? It's building up to hard stuff, but it's not the hard stuff yet. It's just building up. I know there should be quotes. Sorry, my people that are. I would have been talked about it. I didn't put quotes at the end. Polynomial and synthetic division. Oh. Thanks, Paul. I didn't see
Big
it.
brain.
Pop it down. Look at her. Oh no! Okay, got it. Oh, didn't get it. Got it. So if you guys noticed, help when polynomials are hard to factor, which we're getting to because we're getting to the nasty ones. Nice thing is, section 2.3 is not graphing. Section 2.3 is not fully factoring. Section 2.3 is just relearning the divisions. That's it.
Oh no.
Just relearning the divisions.
Please no. Please.
Oh, come on. Guys. Shh.
I didn't like
Shh.
This is the one decision.
Okay, time out. I get it. I get there's dialogue going on in your minds about like, I hate blah, 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 life is awful. The more you talk about it, the more you bring that into reality. Stop. Take a breath. Realize my goal is not to make your life hard. My goal is to make it easier as far as what we need to be doing. So I'm not going to be like, you should know this, go take a test on it. I'm going to reteach it in a way that hopefully makes it better. So, division. What if you are given somebody like this? No.
Yeah.
What if you're given some sort of division problem? Yes, you're all groaning. Shush.
Wait, doesn't the x squared plus 5 have to go?
We're still talking about it and wasting time. So, coming back.
I'll try.
How do we go from here to here? Now, you might not realize that this one is actually way more useful sometimes. You may not realize that it's way more useful sometimes. Just believe me, from my math experience, you don't always want them like that. Sometimes you really want them to look like that as you go on in math. But how do we get from here to here? And long story short, even though this division thing can be used for all sorts of different purposes, eventually it's going to help us with the really hard factoring ones. So what we would do is we would take that dude and we would say, let's do a division. And when you do a division, you put the top, just think, you cut the head off. Like a snake. You want to save yourself, you cut the head off, because that's the part that could hurt you, right? You cut the head off, you drop that head in, well, a bucket. You divide them by the other guy.
Why do you plug 0?
Leave my 0 x. Thanks, Sophia.
Why do you plug 0?
You'll see. Because we got to have columns for 4th degrees, 3rd degrees, 2nd degrees, 1st degrees, 0 degrees. Because when we do our division, it might come through. We might not need it, but we might, so we save a place.
So every single x.
Yep. In synthetic and in long division, we save a place. We ask ourselves, looking at the x's, just looking at the highest degrees, say x squared times what gives me x to the 4th, and hopefully you see it's x squared. X squared times what gives me x to the 4th? Hopefully you see he's x squared. Now we remember all of these guys are little binomials. So when you're doing the normal division things of how many times does it go in, now multiply. You have to distribute that multiplication and you get x to the 4th. Now, Jaden, we didn't need the x cubed this time because check it, that puts us in the x squared column, but sometimes we do. Now division, you multiply and then don't you subtract?
Yes.
The whole thing?
That changes all the time.
Struggle. So you have to remember to distribute that subtraction. Because, once again, the same way we had to distribute our multiplication, we have to distribute our subtraction.
Did you multiply the 5 and the x squared together?
Yeah, because I have to distribute.
Bruh.
Now, I like trying to avoid mistakes. So in my mind, even though to be honest, probably now I just do this distribution of the negative in my head. For way too many kids, that's dangerous. And you should bring that negative inside to make it safe. But either way, if you've done it right, that first term will totally cancel. And then you have to, okay, 0x cubed plus 0 is just 0. So the x cubed term is gone, like it stayed gone. But negative 3x squared minus 5x squared is negative 8x squared. Now I rewrite everything left. I bring it all down. Maybe I need it and maybe I don't. But then we reevaluate, right? How many times does x squared go into, or what times x squared is negative 8x squared? Well, minus 8. You could write it down here above the negative n. It's okay. I just write it up here. Negative 8, and I need to distribute. I will get negative 8x squared, and then negative 40, because I had to distribute it times the 5. It's a division problem, so I must subtract. See my parentheses? See how I'm making everything carefully set up so I won't forget? Are we okay?
Yes.
Looking for how many times it goes in. Distributing to rewrite, and now I must subtract. Once again, mistakes happen. I distribute the negative by changing everybody's sign. Times negative 1 times negative 1 all the way across, so that way I won't make a mistake right here when I go down. The x squares, 8x squares cancel. The 0x isn't, that's a 0. And negative 1 plus 40 is 39. Guys, look at what they said the answer was all along. What do you do with remainders when x squared can't go in? Over the original. You might want to make a note. You might want to make a note. Then we put the 39 over the original denominator. What was in the denominator is still in the denominator. So it's the remainder, if you want to think about it, the remainder over the original denominator.
I have a question.
Out go.
So how does this make us, how does this help us?
Just remember. And you might not have, because I know I say a lot of things and they don't always click. I said that division can be used for lots of different purposes. In future math, you may realize that this is sometimes nicer, but this form is sometimes nicer. Remember with quadratics, the old standard form and the new standard form, they have different purposes. You know, for polynomials, the factored form can be so nice compared to the original form. This form can be way nicer than that form, but for right now, I'm also telling you, hang in there. Eventually, this will be helpful for the really hard factoring problems. Just gotta hang in. Sophia.
Are these questions like y1 and y2 in different denominators, these automatically say they're not verifiably the same?
Say it one more time.
If they give us the same thing, like the y1 and the y2 denominators.
Oh, it's going to be in actual directions, like show that these two are equal.
So even
I
if
just didn't write it all.
even if we know they're not,
They won't get even an Oscar one. They've made them. Guys, there's this thing called a division algorithm. It's just kind of showing you guys what's going on. So this can be used lots of different ways. What we just did is we took an F over a D and we went to division, so you could be going this direction. Sometimes you could be going back the other direction. There are different ways of writing it, but to be honest, this page isn't super important. It's not super important. What's important for you guys to realize is basically just this top part. You can kind of ignore the bottom two parts, and if we need it, I'll talk about it, like in the future. But if you have a division, you can put the numerator in the box, and then you have like a polynomial, then you have a remainder. And the remainder is going to look like, when we rearrange it just a little bit, having a denominator. But once again, that's not a crucial page. So instead I want us to talk about what happens if or when can we use synthetic division. I could take this guy. And I could do a long division. But whenever you have a factor of the form of x plus a, plus or minus technically, remember, it can be a negative, we can do synthetic division as a shortcut. And synthetic division takes all the coefficients, like 1, 0, 0, and 125. It takes the 0 of the factor, which the 0 of the factor is negative 5, puts it in the box. And it follows the procedure of bringing down and multiplying, adding and multiplying, adding and multiplying. And it gets you the exact same thing you would get if you had done the big old long division. There is a shortcut called synthetic, useful for dividing by these little lineages. Can I just ask you to do the best you can on homework for Monday? Is that okay? Okay. If it's something where you're like, it's crazy, we haven't learned this, then just stop and submit it and say, I did the best I could. Sound good? But if you're like, oh no, I can do it, keep going. Bye.